to a panel discussion on digital twins in automation, industrial automation. To guide this engaging conversation, I'm delighted to introduce our moderator, Mr. B. Vasu Devrao, Managing Director of Phytec India, With his extensive expertise in industrial automation, he's perfectly suited to steer this session. Can we please welcome Mr. B. Vasu on stage with a huge round of applause, ladies and gentlemen. Also, please join me in welcoming all our distinguished panelists to the stage with a hearty round of applause as I call out their names, ladies and gentlemen. Mr. Malleswar, CEO of Kalpra Tech, a visionary in technological solutions. Let's welcome Mr. Malleswar. I know we are very few in the audience, but surely we can applaud and appreciate the time the speakers are giving us. Next, can we have Mr. Srinivas Raju, CEO of Bridge Things, known for contributions to IoT and industrial innovation. Can we have Mr. Srinivas? He's a pioneer in automation technology. Can we have you on stage, Mr. Dasari? Welcome, sir. Mr. Srinivas will be joining us soon. No, we have a team going out and we try to push all the crowd inside.
The message, it's the message for the state, it's the message for the group of developers, group of innovators, the group of budding engineers in AP, basically. So why we are putting all our energy and time and money investment is basically to bring all of us together. So to moderate this session, the automation, industrial automation and the edge AI basically. So what we have been talking a lot of AI revolution since yesterday. So we want to change a little bit track of the AI to the real-time AI. Now when I say real-time AI, as you have seen by Mr. Hitesh, bring big session on automotive, right? Like autonomous cars. So tomorrow when we want to bring this, most of the AI in our real life, which we are using at a first hand. Today you are using the AI not by yourself, but by the sellers of you. Like say Amazon is employing AI on every sales of or any product which you are buying from Amazon. So AI is behind it. So today the vendor is using AI, not the consumer. But soon this will change. So the AI will be changed by each and every individual by the means of autonomous cars or like all the health facilities which will be encouraged. We have a lot of industry-specific specialists and domain experts. So I will talk a little bit more on the generic and then advanced robotics and advanced drones. So you would have witnessed one of our AI robo in the our stall, nearby our stall basically. And then Malleswar will bring in his industry 4.0 automation from oil and gas basically, and then Rama sir will bring his huge experience from the railway automation and then the transportation basically. So to keep it a little bit short and more interesting, so what we want to do is let's just address 3 questions basically. So the first is let's define edge AI by the mean of the applications what we are representing the industries. The second thing is basically I want to give little bit of the opportunity scopes, what the developers or the companies or the users can really look into the automation and edge AI basically. right? And the third one is like some of the critical challenges which you have already faced, so that like that could be a good inputs for them, so that like they can also learn from that. So let's answer these three things rather of discussing so many things. So we can keep it. So we can take 6 minutes each. So around 20 minutes or 25 minutes we can close our session.
Thank you, Vasu, and thanks to the organizers for having me. This is Malleswar, Yenugu, CEO of Kalpra Tech Solutions. It's a US, Texas-based company. I did masters from Andhra University in geophysics almost 20 years back. I studied here. Then I worked for Reliance Oil and Gas for 5 years in Mumbai. Then I went to US to pursue my PhD, and now I'm sitting down there. When I started a couple of IT and AI-related companies, and that's where we are developing AI and generative AI kind of products, focusing for oil and gas and healthcare. To answer your questions one by one, Vasu, I would like to define, probably most of you know about manufacturing companies, healthcare or any other industry, but oil and gas is so, narrowed down. Not many people may not be aware of it, except while, we are pumping the diesel or petrol in our cars. So basically, oil and gas industry is defined as three different divisions. We call it as upstream, midstream, and downstream. Upstream means all these companies like ONGC, Reliance, where they go and try to find out the oil and gas. They try to drill and take out the oil and gas from the ground. And midstream is where once you discover the oil and gas from the wells, they have to transport it either through the trucks or through the pipelines till the refineries. That's what we call it as midstream in oil and gas. And the last part is the downstream. That's where once they receive this crude oil, these refineries, like we have all these Reliance refinery in Gujarat, for example, or HPCL or government related, So these refineries, they take all that in legacy crude and they refine it, and that's where they produce all this oil, kerosene, and a lot of other products. So where this edge or AI or digital twins are helping or happening for all these three streams of oil and gas is basically while discovering these hydrocarbons, while to find out where to drill a well, for example, or even after drilling a well, the oil and gas companies, what they're trying to do is, for example, they're drilling through a rig and they're using these advanced AI, edge computing techniques to find out how they can optimize the drilling operations. Because do you know how much it costs to drill one well, especially let us suppose we are in the heart of Krishna basin, in the deep waters. For example, Reliance spends almost like $200 to $300 million. So you can say 1 million is like almost 8 crores. So when I was working there, we used to spend around 1,500 to 1,600 crores in drilling one well. During that time, almost like 10 years back, there was not much automation. We were just drilling based on whatever experts are saying, etc. Nowadays, with the advancement of this edge AI or digital twins, so while drilling, there can be a lot of issues, for example. And if there is any problem while drilling a well, they have to lose like crores of rupees, which nobody wants to. So by using those techniques and IoTs and technology, basically, the companies can able to identify the problems before it happens. That is the advantage of this edge AI. And they are keeping these sensors and this technology at the site, at the drilling sites, so that they identify it, because all that AI and machine learning is happening at this site, offshore or onshore, wherever the drilling is happening. And in real time, they can understand what is happening and they are trying to mitigate the risk so that they can avoid losing hundreds of crores. That is at the upstream level. Midstream level, while you are pumping this crude, if any pipeline breaks down, there will be a lot of leakage of crude. Again, hundreds of crores of loss. And they are using sensors to find out where the leakage is happening. And that information is immediately relayed through cloud to the control centers of these companies. That's why they are using edge AI and AI techniques there. For the refineries, very, very crucial. Let us suppose if HPCL plant is down for a week, you can imagine how trouble it will be. It will be huge problem for the for the consumer market. It will have very heavy impact on our economy as well. So what they're trying to do is, remember, refineries, they come up with a lot of mechanical equipment, a lot of things, pieces are there. They want to understand how they can use AI to identify or predict the maintenance or for any failure prediction, because they cannot take care of, they cannot take into account that if any plant is down for 1 day versus 1 week, it's a huge loss for the country as well as to those companies. So this is where basically all the three streams of oil and gas has been using AI. And another topic is digital twins, because that's where you see whether we being a human being or any plant or any car, for the matter is for oil and gas wells and refineries, etc. What they're trying to do is you're replicating this duplicate of a refinery, which consists of all this equipment, mechanical and electrical equipment. And by using IoTs, we are actually mimicking a refinery, an oil and gas well at the location, at our office, for example. And we just try to play with those knobs. Hey, if I change the pressures, if I change the volumes, how or what is going to happen? So that they want to avoid those mistakes at these sites. Again, it's all useful for predictive maintenance and failure prediction. This is how AGI, digital twin technology, being implemented and used for oil and gas.
Good afternoon. Yeah, basically from my point of view, whatever the technology which we are going to implement, first we have to identify what is the value which we are going to get from the technology. Not technology's sake, in my opinion, nothing is going to work in this commercial world. We can't be doing some researches in the direction of the development something. But when any organization has to be successful, it has to find out what is the value the customer is going to get. So that's the first fundamental point. When we are now talking about IoT and Edge and all that, what is that? Morning from NXP, he given a fundamental thing: sense, think, communicate, and act. But olden days, first IoT means sense, communicate, analyze, and act. So what is that physical parameters which we are sensing with the edge devices, and what type of intervals, that means what type of samplings which we are taking, is also important. Suppose if you are taking a sample of 5 minutes or 10 minutes, in my opinion, that doesn't have any meaning for applying AI and all. Now when we are talking with a smart grid, when we are talking 15 minutes sample, by the time 15 minutes, a lot of things is going to happen. So what is needed is, we need to have a low sampling rate which will tell what is the behavior of the system. That's what's first important in that. When I am taking lower sample rates, the biggest challenge is the bandwidth at which I am going to collect the data to the central place. But for analyzing that, the bandwidth is going to be more is needed. That's one of the challenge. For that, some places will use some of the analytics in Edge itself to identify the patterns in that, only send that information which is an anomaly to the central place, so that with that one can take the action. So in this, what is the value? That's what I am trying to see. Basically, we built almost India's largest IoT network for Indian Railways, almost 7,000 stations, almost every station in India. All signaling elements were digitized. Some of the big stations like Bombay VTR, these voltage stations has something like 2,000 to 3,000 relays that all will be monitored in a real time with a 16 milliseconds sampling period and identify the patterns at which a signaling system has to happen. So when we started monitoring that, any mistakes in the signaling system behavior which will be identified, that's first. That means if it is misbehaving, we'll be having recorded evidence. This is misbehaved at so and so time. By seeing all the old data in a mimic and see why that is mistake. Is it logical mistake or is some system, some element is failed? That can be identified. That's one dimension. The second is when manually somebody is the station master or driver is operating on the system, then what is going to happen? They do mistakes. When they do mistake, we will be able to see the recorded evidence and find out why that mistake is happening. From long time, one of the biggest mistakes used to happen in the railways is driver crosses the red signal. When the driver crosses the red signal, there is no evidence that he crossed. Then the railway officer started seeing this data. Whoever crossed the red signal, through the pattern they identified, and they will be able to give a summons, and thereby the discipline is brought. Similarly, the station masters, whatever they are doing mistake, by implementing the discipline into the system, they are able to reduce the accidents. That's a good back. That means if there is something like 20 years back, there used to be multiple accidents. Now the almost accidents came down because continuously monitoring the data and identifying. The next dimension is when something is happening in station, but the control is happens in a divisional headquarters. Suppose all the stations, whatever is there in the jurisdiction of the, say, Vizag, almost some 100 stations will be that side, this side. All that has to be controlled by some controllers sitting in Vizag. This fellow doesn't know whether the signal is given to that station, where the train is, and how really what is happening. Is there anything or choke? All that data is brought and showed it as a mimic in front of these controllers. Their train is at so and so place, and the signal is red, green, and where the things is moving. This is where, by giving a entire simulated, real-time simulation of the entire network, we will be able to show to the people that these are things happening, so that he can use the planning more effectively. This is what other side people are talking digital twin. In my opinion, it's not exactly digital twin. First is only a real-time dashboard, which is coming less than something a second. The data is visible to him in a real time. That's one dimension. The other dimension, which now we started working with, if you take any railway system, any asset field, automatically what is going to happen is entire line get tested. So if you want to reduce that, you need to understand where the failure is. Suppose if you take a station, there is some controller is there, controlling the entire signal. The controlling system will send some signals to us, say for example, signal to lit into the green. But unfortunately that is not getting into the green, that is failure. Then how this fellow knows where the mistake is? There are wires, there is a power supply, there is intermediate relays, and finally the equipment of that lamp has to be lit. But what happens is, if somebody has to identify the mistake, he has to understand, take multimeters and the thing, check step by step. It is a more than 1.5 kilometers distance, walking and going. It will take almost maybe couple of, at least minimum half an hour to 1 hour. So, if I am able to get all the data at a particular locations, show it on his mobile as a dashboard, automatically he will know up to this voltage is coming, and here the current is flowing, this is failed here. So he will be able to locate to the nearest point and be able to understand. That is the way the use case is going to get the outcome. Now he is able to go directly to the spot, maybe within 4 or 5 minutes he can rectify that. So here what is happening is, you need to put a lot of edge devices, bring all the data to the central place and create that on a mobile as a dashboard. This entire system has to work in a real time. That means the data collection and bringing it to some central server. Now from central server, you need to put everything into your mobile, whoever seeing that as a dashboard. If entire cycle has to happen in a real-time refreshment at every 1 second or half second, and simultaneously this data should be visible and mimic. When that is mimic, there are two things, another thing happens. One is on his circuit, also on his mobile. On the circuit, the data is imposed, so that he will be able to understand without referring the circuit. The circuit is available on the same mimic, so that we'll be able to see the things. This is how really the values is going to come. Once we try to identify the various scenarios and where more failures is coming and this type of failures is coming. Suppose if you take there is a one system called point vision, there is a series motor is driving the say rail from one side to the other side. So initially the unlocking is happening where the spike current comes. After that some steady current comes when it is moving. After that again it has to lock. Again the end spike comes. If the signal is going to be the same way, that is a properly operated. If there are some mistakes, some carbon brush failure, or somewhere say the lubrication is not there, because of that the signatures will vary. If that signature variation, if you are able to identify through the AI, we will be able to identify exactly what is the problem. Thereby, we will be able to suggest, okay, before failure itself, we can be able to say your carbon brushes is getting worn up, or otherwise your lubrication has to be done, or otherwise your tongue rail or the rail is not having higher spring load or just something. These are all the dimensions which we can bring with the help of edge devices. And the entire unfortunate thing what is happening in India is two things which are happening. We have already, entire world, 280 billion ARM processors were sold. Some of the ARM processors are as low as $0.2. So how we have to use that ARM process and build the solutions around it. Not I will buy Raspberry Pi or some other module and build on it again with what is called real-time OS. That means this we are building a fatty system. That fatty system will not be cost effective and it's going to be not going to be a solution. We need to build all edge devices with a low cost, with a writing a code on that. That type of knowledge has to be bring. Unfortunately, in India we don't have proper courses in any of the universities, including IITs. This is the first thing which we have. Second thing is, all that which we are all trying to do is using the platforms, left and right. AWS platform or that, we want to make it very quick. Unfortunately, we are going to pay a huge fat amount to whatever the cloud services company. End of the day, the startups or the who are starting or the business they are trying to do, they are not able to make money. Only the big companies are able to make money. I am not against that. If you have more value there, use it. If you don't have value, making that and trying to build your solution, it is end of the day, your organization will not be successful, which we need to bring the cost down also, is the most important, and scalability also more important. These are the few of my comments.
Thank you, Rama sir. So just to add to Rama sir part, so today when we say AI, it's a big jargon. Like when we say AI, at least one name which comes is NVIDIA, right? So I will give you my practical experience of 2 weeks back. We do a lot of technology sessions, and I ordered one receiver to 4 transmitter mics, BT mics basically, which costed me around 12,000 rupees. So if you can say 12,000 divided by 4 devices is basically around 3,000 rupees. It's just nothing but whatever the roads or whatever you see, everyone, YouTubers at least basically, right? So now, in this device, if you really see, so there is a MCU, there is a audio section, and interestingly, the company has put a AI core to do the noise cancellation or all the DSP things on the chip. And if you open the board, hardly you will find not less than 20 components on the PC. So the box which you see in every video, you will find only 20 components, and the biggest component is the processor. And interestingly, it was RISC-V processor with the AI core with all the specific application to the specific need. So when we speak about the AI, it's not about all the images. Yes, the first level of AI is more easy in terms of video analytics or the image analytics. The second one is your natural language processing, basically. So this is what the most common one which goes to the people. But as an engineering background, right? So when from coming to the industry or coming to the technical, so we have a lot of legacy in the knowledge in terms of electronics, in terms of embedded systems, basically. So we have to bring this. So we can bring a lot of AI into real time. So when I'm saying that like I'm transmitting this, so this is not exactly a Bluetooth mic, but so when I'm transmitting this, so it has to transmit, before the transmission my voice has to be rectified with any noise which is going into the mic. So that has to happen into this mic. So now, will the AI reaches this? It's already reached. Only the thing is it's not with the common people language. So I believe we will build a lot of our software knowledge. India is being proud to be a software country, but this software country we have to bring the real into our real devices of the life. So being at Phytec, so we build the processor modules starting from your Cortex M0 which runs at 25 megahertz or to the Cortex A72 which can boost up to 2 gigahertz. So we help the product manufacturing companies with our system on modules basically, and we are helping. So what you saw, the AI robot, right? So when you talk about a robot, so you have the mechanical parts, the motor drivings, the sensing parts basically, and you have the normal operations which is done by a simple compute. But now you have to make this robot connected to some business case. So that is what I believe as an Indians we have a big advantage as we can easily code in C or Python basically. So these are the things which can easily enable our developers or our forefronters basically who can bring the value to the real-time applications, right? So similarly on the drones, so the basic drone functionality is already available, but how you can connect it to the Industry 4.0 or your medical healthcare or preventive maintenance. So all these things we can do, and I believe next session is our electronics. So we will also discuss a little bit on the real-time implementation of these hardware devices. I will try to wind up this session so that we can go for the next session. But any other queries if we have, so always we are present, and then our contacts are already available. We all are part of mentors of digital technology industry group. So DTI is the industry group for Visakhapatnam. We wanted to achieve the economy target of Andhra Pradesh. So we strongly believe that building a strong ecosystem around Andhra Pradesh would help us to achieve this dream of bringing our state to the next big position in our country. Thank you. Once again, I thank you, the panel members.
Everyone, for such an encouraging and thought-provoking session. I would like to request Mr. Dr. Rama to please come forward to felicitate our guests. Mr. Malleswar, CEO, Kalpra Tech. Mr. B. Vasudeva Rao, Mr. B. Vasudeva Rao, and Mr. Krishna Dasari. Thank you so much, gentlemen.